I'm going to have a look at 2013 January, the C3 paper. And I'm going to start off with question 3. So it says, show that this expression can be tidied up like so. So basically, fractions means factorize. So x plus 4x minus 1, difference of two squares here on the bottom. To divide fractions, you turn the second one upside down and you multiply. And knock off any terms which are common to top and bottom. So this cancels in this, leaving you with 3x minus 5, x add 4. Part 2 of this question asks you to use the result of above to differentiate this. Now this is the expression above. So basically what it's asking me to is to differentiate the answer to part 1. Now I like to write it as y equals, makes it look a little bit easier to follow. So y equals 3x minus 5, x add 4. So u is the top line, du by dx is 3, v is the bottom line, dv by dx is 1. It's a quotient rule, so dy by dx is v, du by dx minus u, dv by dx all over v squared. So v is x plus 4, put brackets around it because it's more than one term, du by dx is 3, minus u, again, put brackets around it, dv by dx is 1, all over v squared. And tidying that up, the top line, 3x minus 3x disappears, 12 add 5 is 17 over x add 4 squared. I have another one I want to do out of this paper. It's question 7. So we just scroll down to find that. Question 7. Find the equation of the tangent to this curve. So y equals e to the 3x cot a half x add pi over 2. And I want the equation of the tangent. So just structure your question. You're told x is 0. So let's work out what y is straight off. So y is e to the 0 cot pi over 4. So e to the 0 is 1. And that's tan pi over 4, which is also 1, so that gives me 1. So plugging that in, y minus your y coordinate is mx minus your x coordinate. To work out your m, it is to differentiate this. So u is the top, and sorry, the first term, v is the second term. To differentiate the top, or an e, it's the derivative times the function. To differentiate a cot, it goes to minus cosec squared, and the derivative of the function is a half, so that must go in front. So pulling it together for dy by dx, so it's the product rule, u dv by dx plus v du by dx. U is e to the 3x, dv by dx is this expression here, so minus a half cosec squared, a half x plus pi over 4 plus v, so it's a cot a half x plus pi over 4, and du by dx is this expression, so it's 3 e to the 3x. You're told that x is 0, so let's plug that in here. So dy by dx, e to the 0 is just 1. So I've got in this one here, minus 1 over 2. Cosec is over sine, so sine squared. Put x to be 0, so it's pi over 4. Plus, cot is tan in the bottom row. X is 0, so you're left with pi over 4. The top has got 3 e to the 0. E to the 0 is 1. Sine pi over 4 is 1 over root 2. You've got to square it, so 1 over root 2 squared. E to the 0 is 1, and tan pi over 4 is 1. The bottom becomes 1 over 2 times 2. So that becomes minus 1, add 3, which is 2. So your gradient is 2. Just plugging it over here, y minus 1 equals 2, x minus 0. So y equals 2x, add 1.